Hello everyone. In this particular video I'm going to be explaining to you about the difference between the two operators, which is a shift right operator and the shift arithmetic right operator of 8086, and this I'm going to be explaining with the help of EMU 8086 operator. So this is the shift right operator in which I'm going to specify the register data which I'm going to shift and by how many bits I'm going to shift the particular data that is specified after the comma. And similarly the shift arithmetic right is you're going to specify the register again over there and you're going to specify by how many bits you're going to shift it over here. So we'll be looking into the difference between shift right and shift arithmetic right. The basic difference over here is the first most significant bit is replaced by 0 when it comes to shift right, and the most significant bit over here is replaced by the sign bit on the SAR over here. That is the only difference over here. Any shift you do, you're going to replace it by zeros when it comes to shift right. How many number of times you should use the shift arithmetic right, the most significant bit is going to be replaced by the sign bit. If it was a 1, it is going to be replaced by 1s again over here, and if it was a 0, it is going to be replaced by zeros again over here. So we look into that with this example. So initially for this shift right, what I'm going to do is I'm going to move a particular value of 0, 1 into AL register. Similarly for this shift arithmetic right, I'm going to move 0, 5 over here, in which my sign bit is 0 over here. So you will see that 0 is going to get shifted over here on the right. But in this example over here, again shift arithmetic right, I'm going to give the most significant bit as 1 over here, so that you would see the difference of the most significant bit getting replaced by 1 always. So we'll move on into this particular example. So you can see that I'm going to first execute move AL, 01, and before we go into the execution part, let us look at the flag values for now. So as we know that when a shift right operation is done, the least significant bit is moved into the carry flag. So you may be aware that when I execute move AL, 01, AL value is now updated with 01 over here. So 01 is nothing but 4 zeros followed by 3 0 and 1. So what is going to happen over here, the least significant bit which is 1 over here in the binary representation, that particular 1 value is going to be moved to the carry bit over here. So you can see the carry flag will now become 1, and as it is moved outside over here, all other bits are going to become 0. So because the most significant bit is replaced by a 0 over here, so it is going to be 4 0 4 zeros over here. So this AL register is going to become 0. So the 0 flag is also going to be enabled over here. And that is what you see over here. The carry flag, whatever was in the least significant bit, that bit is moved into the carry flag, and now the most significant bit is replaced by the sign bit. The sign bit over here is 0, so 0 is replaced on the most significant bit over here. So you have 4 zeros, which is nothing but 0 0 here. So your 0 flag value is enabled, and you may be aware that I'm giving shift right of 2 times. So what is happening over here, shift right is going to happen another time over here, and you will see that AL will not have any changes because 0 0 there is no value to be shifted on the, there will be no changes of value shifted, whereas you can see that the least significant bit which is 0 is going to be moved to the carry flag. So this will be the only change that you will be monitoring over here. So you can see that the carry flag alone has become 0, whereas your AL value is still at the particular 0 0 0 value. So the 0 flag is still 1 over here. Next we are going to look into an example for shift arithmetic right. So what is going to happen in shift arithmetic right, as I told you, the least significant bit is moved to the carry flag and the most significant bit is replaced by the sign bit. If it is a 0, it is replaced by a 0 there, or if it is a 1, it is replaced by a 1. So let's look into an example where 0 5 is moved into AL register. So that is what is going to happen over here. So 05 is moved into AL register now. So you know that 05 is nothing but 0101 in calculator. So you know that when it comes to 5 is nothing but 0101. So what is going to happen is the remaining 4 bits are 0000 here. This particular 1 is moved to the carry flag over here, and the remaining value is 010, that is shifted to the right. So you know what is 010. So 010 is nothing but 2. So you can see that this 5 will be replaced by 2 over here. So now we'll come back into this particular program. So 5, you will see that the carry flag value is now going to become 1 over here, 0 flag will become 0 here, and you can see that the 5 will be replaced by 2. So you can see that the 5 is replaced by 2 over here, carry flag is being enabled over here. So this is what is happening in this particular operation. Next, what is happening over here, I have a particular value of 0, 1, 0 here. I have a value of 0, 1, 0 here. Now I am shifting it towards the right again. So 0 is at the least significant bit, so my carry flag is going to become 0. This 0 is going to go to the carry flag over here. So it is going to go to the carry flag, and carry flag is going to become 0. And next, what is going to happen, my 2, you can see that my value of 0010 is going to become 0001 over here. So what is 0001? It is value 1. So you can see that in this particular example over here, when I run this step again, 02 will now become 01 over here, and the carry flag has become 0 here. So this is the example in which the particular most significant bit was considered to be a value of 0. Now we'll consider the last example over here, where the most significant bit is considered to be a particular value 1. So when we execute this particular value, 80 is moved into AL register. So 80 is moved into AL register. So according to the calculator, you may know that if I have a hexadecimal value of 80, it is nothing but 1 followed by 7 zeros over here. So 1 followed by 7 zeros, and least significant bit is 0 here. That is going to be moved to the carry flag over here. So carry flag will be 0, and you can see that this 1 is shifted to the right over here again. So it is going to become 11000000. So what is 1100? That we need to know. So this particular value 8 is now going to be, this 1 is going to be shifted over here. So it is going to become 1100. So 1100 is nothing but C. So you can see that when I execute this particular step, 80 has become C0 because the sign bit has now been shifted to the right over here. So C0, and my carry flag is still 0 because I have a 0 here. Now if I shift it one more time, what is going to happen? You can see that 1100, it is going to become 1110. So you need to know what is 1110, which is nothing but E. So you can see that my particular value at the least 4 bits is 0000. So that is going to be moved to the carry flag. So there will be no change over here. And the C value, when I shift it by 1 over here, as you saw in this example, I will get 31 followed by a 0, which is E. So you can see that it becomes E over here. So E0. Now you know that according to this case, if I'm going to have 3 ones over here and I shift it once more, it is going to become 4 ones over here. 4 ones is nothing but F, as you know it. So you're going to have 4 ones over here. So 1, 1, 1, 1. So it is going to be F. So you see that the value in the carry flag is not going to change after this shift arithmetic, right? Only the particular value of this accumulator value will become F0 here. So you can see that the value of E0 has become F0. So that is the difference between SHR and SAR. Shift right and shift arithmetic right. The most significant bit is replaced by the sign bit in the case of SAR. The most significant bit is always replaced by a 0 in the case of shift right. I hope you were able to understand this particular example. Thank you.